Okay, so in this video, we're going to look at an important part of the structure and bonding topic, which is explaining shape, polarity, and solubility. Now we're going to look at all three because they're all related to each other. Like, to explain the solubility, we have to explain shape and polarity first. Or if we were just explaining polarity, we have to explain shape and polarity. Or we could just explain shape if we wanted to. But the three are tied together, so we're going to look at an example of comparing the solubility of two molecules, PCl3 and BCl3. Now where we start with this is we start by drawing Lewis diagrams. So let's begin with PCl3. Remember, what we work out is those four numbers A, B, C, and D. So A is how many valence electrons the atoms currently have in total. Now phosphorus, you'll see on the periodic table, has 5, and each chlorine has 7. 7 lots of 3 is 21, plus 5 is 26 valence electrons that they have in total so far. B is the number of valence electrons that the atoms will have if all of the atoms have a full valence shell. So that would be all 4 of these atoms having a full shell of 8 electrons, which would give us 32. C is the difference between those two numbers, which is 6, and D is C divided by 2, which is 3. Now D is the key figure. That's the number of bonds that we're going to have in our molecule. Okay, so our central atom is going to be phosphorus. I'm going to draw that P in the middle, and I'm going to draw, I've got my 3 chlorines, I'm going to draw those around my phosphorus, and I've only got 3 bonds, so that's going to work nicely, just 3 single bonds. Then we want to fill up all of the atoms so that they have a full valence shell. So each chlorine currently has a share in 2 electrons, so we need another 1, 2, 3, 4, 5, 6 to make sure that they've got 8. The valence electrons around the outer atoms are not actually that important. It's more the central atom that we're interested in, but I'll draw these ones anyway. Now the phosphorus has a share in 1, 2, 3, 4, 5, 6 electrons, so we're going to need 2 more on the central phosphorus atom. And it's that central atom that we're most interested in. Okay, so what we then talk about is we want to explain the shape of the PCl3 molecule. So we'd say something like this. There are four regions of negative charge around the central phosphorus. These repel to a position of maximum separation to a tetrahedral shape on an angle of 9 degrees. Okay. So just to go over what I'm saying there, the central atom has 1, 2, 3, 4 regions of negative charge around it, and these push each other apart as far as possible, so they repel to a position of maximum separation into a tetrahedral shape. Okay, so when you have 4 regions of negative charge, they push each other apart into a tetrahedral shape. It's a 3D shape, which has a bond angle of 109 degrees. That's the first thing with the shape. Then we say that there are 3 bonding regions and 1 non-bonding region, which means the final shape of PCl3 is trigonal, pyramidal. Okay, so that's explaining the shape. So we draw the Lewis diagram, we look at how many regions of negative charge there are, what the base shape is, which in this case is tetrahedral, and then depending on how many of the regions are bonding and non-bonding, it gives us the final shape, which in this case is trigonal pyramidal. Okay, from there we go on to explain polarity. So we'd say something like phosphorus and chlorine have different electronegativity. Means that each PCl bond is polar. Okay, so now just remember, electronegativity is a measure of an atom's pull on the shared electrons. Okay, so here we've got phosphorus, we've got chlorine. We're interested in like which one has the stronger pull on the shared electrons. I can't remember off the top of my head. Let's just say that chlorine is more electronegative. That would mean that these shared electrons are pulled closer to the chlorine than the phosphorus, making this end of the bond negative and this end positive. That's what electronegativity is. It's a measure of the strength of an atom's pull on the shared electrons in a molecule. So the bond is polar. Each PCl bond is polar. Then we talk about the arrangement of those bonds around the central atom. As phosphorus and chlorine have different electronegativities, which means that each PCl bond is polar. Polar bonds are arranged asymmetrically, that means non-symmetrically, around the central phosphorus. That polarities do not cancel out, and the molecule is polar. Okay, so we talk about the polarity of the individual bonds, and in this case, those polarities don't cancel out because the molecule is not symmetrical. Okay, trigonal pyramidal is not a symmetrical shape. So then the polarities do not cancel out, which means the overall molecule is polar. Okay, what this means in terms of solubility is that because PCl3 is polar, going to dissolve polar solvents such as water. Alright, so that's PCl3. We've explained the shape, we've explained the polarity, and we've explained the solubility. Now let's have a look at BCl3. Now, boron is a bit of a special case. Firstly, working out A is the same. Okay, A is the same. So boron has 3 valence electrons. Each chlorine has 7, so that's 21 plus 3 is 24. Now, boron is a special case. When it has a 4 valence shell, it only has 6 electrons, not 8. And this is something you have to remember. Okay, so what we're looking at is boron not having a 4 valence shell with 8, but just having a 4 valence shell with only 6. So that means that we're going to have 6 plus 3 lots of 8, 3 lots of 8 is 24, 6 is 30. So 30. C is the difference, which is 6. And D is that divided by 2, which is 3. So again, we're just going to have 3 bonds, which means that we're just going to have single bonds. And our molecule is going to look pretty similar to the one that we just drew previously. So we're going to have boron, we're going to have the chlorine atoms arranged around the boron, and we've got 3 single bonds, so it just goes like this. Now, we have to draw our valence electrons on the chlorines, but the boron already has a share in 6 electrons. And because boron only needs 6 electrons to have a 4 valence shell, that's all it gets. We don't draw any more electrons on the central boron atom. Okay, so now this time there are 3 regions of negative charge. central boron atom. Again, these repel the position of maximum separation to a trigonal planar shape on an angle of. Now here there are three quantum regions, 0 non-regions, common shape is trigonal, same as the base shape was trigonal. Okay, so let's explain the shape of BCl3, the final shape will be trigonal planar. Then we talk about the polarity of the molecule. So boron and chlorine have different electronegativity, which means that each BCl bond is polar. Polar bonds are arranged symmetrically around the central boron atom. This means the bond polarities cancel out and the molecule is non-polar overall. Okay, so if I was to draw, if we draw this, sorry, the way I've drawn my Lewis diagram, it looks, it doesn't look symmetrical. But if I was actually to draw it accurately, it would look like this: Cl, Cl, Cl. Okay, it's actually a symmetrical shape. So because of that, the polarities cancel each other out because it's symmetrical around the central phosphorus atom, and the overall molecule is actually non-polar. Okay, then lastly we say because BCl3 is non-polar, it will dissolve non-polar solvents. It will not dissolve in polar solvents. The rule is like dissolves like. Polar dissolves polar, non-polar dissolves non-polar. Okay, so that's how we'd answer this question. And just to recap, we've looked at explaining shape, polarity, and solubility. Now we could have a question that just asked us to explain shape, to explain polarity. So if the question was compare the polarity of BCl3 and BCl3, we'd do exactly the same thing. We just wouldn't give our final statements about solubility. We'd still have to explain, we'd still have to draw the Lewis diagram, we'd still have to explain the shape, and then from the shape we get the polarity. Or we could have said compare the shape of BCl3 and BCl3, or the bond angle. In that case, we wouldn't talk about the last two parts, we'd leave off these parts and just have the shape. Okay, but because we've asked about the solubility, we have to go through the whole process of the shape, explaining the shape, and then from there explaining the polarity, and then using that to explain the solubility. So that's explaining shape, polarity, and solubility of molecules.